is life. Physics can explain everything and anything that happens in our universe. And it's also a required class in my school district. But that's not the point. The point is we are going to be focusing on the property of inertia and Newton's first law of motion. Newton's first law of motion states that an object in motion will stay in motion and an object at rest will stay in rest unless an external force is acted upon it. So let's see what happens when the external force of my foot is acted upon this medicine ball.
Now, before I explain what just happened here, we have to fully understand two things: inertia and Newton's first law of motion. But because I already explained Newton's first law in the beginning of the video, what we are going to talk about now is the property of inertia.
Inertia is an object's resistance to change in motion. And what I mean by this is, if an object is at rest, it will want to stay at rest. But if an object is in motion, it will want to stay in motion. And the object's resistance to this change all depends on one thing. That thing being mass. The greater the mass of the object, the greater its inertia will be. But you may be thinking, wouldn't its inertia depend on both velocity and mass? And the short answer is no. An object's momentum is what depends on both velocity and mass. But that's another topic for another time. So when I go through the explanation, just remember, inertia is an object's resistance to change in motion.
In the beginning of this trial, the medicine ball is at rest, and it currently has no intention of changing its motion. However, the force of the kick is great enough to overcome the inertia of the ball, causing it to change motion in the direction of our test subject, Andrew. Finally, when the ball impacts Andrew, he falls over without any action on his part, showing that the force of the ball's impact was greater than his own inertia.
See what happens when we get a test subject whose inertia is greater than that of the medicine ball. This is our second trial, testing what happens when the inertia of our medicine ball goes up against the inertia of one of my friends.
Let's break this down. Just like the beginning of trial 1, the medicine ball is currently at rest and has no intention of changing motion. And once again, the force of the kick is great enough to overcome the inertia of the medicine ball. However, unlike our previous trial, it appears that our new test subject, Prem, has a greater inertia than that of the medicine ball. This causes the medicine ball to bounce backwards as opposed to our test subject getting pushed forward.
And as you can see, physics can explain even the smallest parts of life. So when you want to kick a giant medicine ball at one of your friends, remember who you have to thank. Thank you, Isaac Newton.
What is this? Okay.